We're going to learn about inverses of matrices. Now, normally when you're talking about a group, in this case it's multiplication, you've got this thing called the identity. So if we're talking about timesing, you know that any number times 1 is itself, and 1 times any number is itself. But really importantly, if you're timesing A with something called A inverse, you should get 1. And also if you got A inverse times A, you should get 1. And if we're talking about numbers, this is pretty easy to work out, because if we do 3 times a third, we get 1. And if we do a third times 3, we get 1. It can be a bit messier, like if we have 7 over 12, we'd have to times by 12 over 7 to get 1. But basically, if we're talking about real numbers, to do the inverse, you just flip it upside down and do the reciprocal. But if we're talking about matrices, it's a little bit trickier. So here's an example. We got this matrix 2, 5, 1, 3, and it seems like its inverse is this. How do we check that this is its inverse? Well, when we times them together, we get the identity matrix, which is our equivalent of 1. And if we times them the other way together, we get our identity matrix, which is the equivalent of 1. So we say they're multiplicative inverses. So if we called this matrix A, this matrix would be called A inverse. And we have A times by A inverse always gives us the identity matrix. So it works the same way that inverses work in timesing. Now, to do inverses, the formula is a bit involved, but once you get used to it, it's pretty simple. We work out this thing called the determinant, and that's just made up of AD take BC. So you essentially times those two numbers, and you times those two numbers, and you take them away from each other. Then we flip some things and negate some things. Anyway, what we're going to have to do first here is we're going to find the inverse. So we'll call this matrix A. A inverse is going to be 1 over det A times, you flip the 3 and the 2, so you get 3 and 2, and then you negate the other one, so minus 4 and minus 1. Now we'll work out what the determinant of A actually is. I might do it off to the side here. The determinant of A is 2 times 3, so the diagonals, take 1 times 4, the other diagonals. So that's 6 take 4, which is 2. So let's work this out. 1 over 2, 3 minus 4 minus 1, 2. And that just simplifies down to 3 over 2 minus 2 minus 1 over 2 and 1. That's our inverse. Now, if you want to check, you could times A with A inverse and you get the identity matrix. All right, same process for this. Find A inverse. A inverse equals 1 over. Now, the determinant is going to be minus 2 times 5. Take away 1 times 3. So we just keep that in mind. We're then going to flip these numbers, so 5 minus 2, and negate the other numbers, minus 1 minus 3, just like that. So this is going to be 1 over minus 13 times 5 minus 1 minus 3 minus 2. So what we're left with is 5 over 13 negative. We're going to get 1 over 13, 3 over 13, and 2 over 13. That is our inverse A inverse. And if you want to do that on a Casio, we can just double check that. So you would go matrix to enter the matrix. You would enter it exactly as we've entered it here. You'd then exit out. You'd go shift matrix alpha A to the power of negative 1. And that will give you the inverse on a Casio. There you go.